Okay. Um, we're starting gas laws. So today's assignment, we're going to be working with Charles Law. So two things you need to have out with you. When you have your worksheet, obviously, I want you to have your note card that has the different laws, their formulas, and information regarding the relationship, other and the units that are involved. It also has their temperature conversions. And you're also going to need your calculator. Okay, so for Charles' law relates volume and temperature, and it's a direct relationship, meaning if one of those variables increases, so does the other. So what I like to do is I always like to rewrite on this page um, the formula, just in case I don't have my formula card with me. So for Charles' law, it's volume 1 over temperature 1 is equal to volume 2 over temperature 2. So when we look at example question 1, you have 4 variables, you're always given 3. So when we read this, it says we're going to calculate the decrease in temperature when 2 liters at 315 Kelvin is compressed to 1 liter. Alright, so where do those numbers fit in? So again, something that I like to do is I will list out my variables. So V1, that's my first volume. Temperature 1 is my first temperature. V2 is my second volume. And T2 is my second temperature. So one of those is missing. Alright, so 2.0 L, well that's a liter. So when I look at my note card, if you don't know what a L is, there that stands for volume. So there's how you can match up. Any number given milliliters, liters, or cubic centimeters is a volume. Since that's my first one, that's my volume 1. So it's 2.0 liters. The next number is my first temperature. So K, so here's T stands for temperature. It's already given me in Kelvin. Okay, so I don't have to convert Celsius to Kelvin. So it'd be 315 K. Now my third number, it says it's compressed to 1 liter. All right, so it's my volume. That's my second volume. So 1.0 liter is my second volume. So which means is I'm missing my second temperature. And also says calculate the decrease in temperature. So that was kind of my hint of what I'm looking for. So we're looking for temperature. So I'm putting a question mark there. So now I'm going to take these numbers and plug it into the formula. All right, so my V1 goes on top. So that's 2.0 liters over T1, which is 315 Kelvin, equal to my V2, which is 1.0 liters, over my T2, since we don't know what that is. So once we're in this setup, we're going to cross multiply. So when we look at which numbers multiply first, the pair of digits, so we're not the one with the missing variable, so we're going to multiply these two numbers first. So 315 times 1, which we obviously know is 315. Then we're going to multiply 2 liters times T2. So what it ends up looking like is we have 2.0 liters times T2, and that's going to be equal to 315 times 1, we know is 315. But it would look like this mathematically. 315K times, let me move over a little bit, 1.0 L. So now you want to get T2 by itself. So how do we do that? Well, we have to divide 2 to both sides. So 2.0 liters, 2.0 liters. So we know that this is going to cancel out. That leaves T2 by itself. So this is what we're going to solve in our calculator. So what we would do is, on our calculator, we'll do 315 times 1 equals, then divide it by 2.0 equals, we got 157.5. So 157.5. Now, since we're solving for temperature, what's the unit? Well, our temperature always needs to be in Kelvin. So it's 157.5 K. And there's our final answer. Always circle it. So again, I showed all the work for this, which you didn't have to. What Ms. McNamara and I are ultimately looking for is that you identify your givens, like you did in the question, or off to the side, plug them in to the correct formula, and then cross multiply. And then I just showed you all the work by hand and how to figure this out. However, at this step, you can stop at this step where you can just plug in your calculator and then look for the correct answer. Okay, so that is your example on how to solve for Charles' law.